My name's Haley Mills. I am a security strategist over at Splunk, which means basically I make PowerPoints for engineers rather than doing actual engineering. But I got to build this back in my day, and I think it's such a powerful concept that I haven't seen enough penetration in the security tooling community to be enabled to do it. So we're going to talk about how you can do it and how awesome it is. So what am I talking about? Splunk calls it risk-based alerting. Risk is a weird term. It's used by the business for a lot of things too. So I'll name another term that maybe makes more sense as to what that actually is. But then we'll talk about how we actually do that. And you don't need Splunk. Really, it's just a methodology. And when I was introduced to it, it solved all the problems that I was trying to solve as a detection engineer, mainly not making my analysts unhappy by making them crappy alerts all the time. And so we'll talk about how you would do that with whatever tooling you have. And then we'll talk about what you can do after you've built it, which is the coolest part, because you can just keep bolting on features and doing really cool stuff. So what talk all about? So this has been the detection methodology for a long time. And I mean, for a lot of use cases, it actually works great. But you have a security log, you write a detection on the log, and out pops an alert. But when you do this 50 or 100 or 200 times, you just keep getting alerts, and there's so many alerts. And we can try and deal with that by tuning the detection or suppressing results, allow listing known business goods. But I think there's a great use case for these one-to-one detections, but ultimately we can't rely on it, especially for subtle behaviors, like the tiny little fingerprints that attackers leave. I know I can't alert on like run DLL32 ran something I've never seen before, or like multiple users on a system. Those things are great they're great observations, but maybe not great alerts. So problem is that we've got like the data for our MITRE ATT&CK techniques to look at, but there's so many cool things there that I would never make an alert on unless I wanted the SOC to put cyanide in my coffee, because I was an analyst first before I became an engineer. So when I became an engineer, I realized how hard it was to make alerts that didn't suck. And if I made an alert that was a false positive 1 in 10 times, but that 1 in 10 times was every week, I gave them 10 alerts per week, even if it takes 5 minutes at the minimum to investigate. It's 40 per month, 480 per year. That's 40 work hours, just basically working a crappy alert that is only a true positive 1 out of 10 times. So a solution for that is what Splunk calls risk-based alerting, but I would maybe say more accurately, it is aggregated abstraction alerting. We are making abstractions of behavior, we're observing behavior, and then we're aggregating those and alerting when the aggregate is interesting. So I've actually tried to see how far back this goes in the security community, because in a 2012 Black Hat talk, someone named John Flynn talked about doing exactly this. But I think it just sort of got muddled where like the people who are doing this and succeeding. The people who aren't doing this have analysts who work the same crappy alerts over and over and over again. And so I'm really passionate about like exposing this concept to the community, so we're all on the same page and we can all make really, really cool detections. So my story, well, if you go way back, I used to draw cartoons for a living, but 80 hours a week, 40 hours of pay, and living in Los Angeles, barely survived. So while I was having my quarter-life crisis, a friend in cybersecurity offered to mentor me, and thank gosh for him, because I really enjoy what I do now. So I started as a SOC analyst, and again, I was just working the same alerts over and over. We were using Splunk, so I was able to make like dashboards and workflows to like make my crappy alert investigation swifter, but ultimately I was still unhappy and I wanted to make alerts. So eventually I became a detection engineer, and that's when I realized how hard it is to make an alert that doesn't suck, because no matter like, so my method was I would like build an alert in our EDR tool and then wait a week, see how many false positives I can tune out, that's regular business traffic, then wait a month just so I could try and find more of those weird regular business activity things, and then deploy. But even sometimes after a month of tuning out regular business traffic, I would still just, every week there would be a new false positive. And so I would have to tune, and it was a constant process. And I tried to do what I could, but in 2018, I went to Splunks.conf, and the lovely Stuart McIntosh, who works at a company called Outpost Security, and Jim Apker, previously of Splunk, they talked about this concept, and I was gripping my chair and like my brain just thinking about all the possibilities, because as soon as I got back, I sent the talk to everyone. I was like, we have to do this. And even though everyone was on board, On High said, well, actually, you have to cover 100% of the MITRE attack framework, which is not how that's meant to be used. But regardless, while we were building it out, anything that we couldn't cover, because there's so many cool things in MITRE, but it's more of like forensics on attacker behavior than a detection library. So there was a lot of things that they were so noisy. We were just like, well, we can do this next year with RBA when we build it out. So that's what we did, and we just had incredible results. And so now working at Splunk, I help people with this as much as possible. I evangelize it, talk about building it from the ground up. And so common results. I mean, it really depends on what alerting is in place to start with, but anywhere from 30 to 90% alert reduction. My personal experience was 1,500 alerts a week to 100. And the analysts were like, hey, is the thing you built broken? Because it doesn't feel like it's actually working because we're not working that much. Or they just had so much more time to investigate. And there was also just vastly increased alert fidelity because we were aggregating interesting things and alerting on those aggregates rather than one-to-one direct alerts for everything. And then what I loved is we were able to cover huge swaths of the attack framework. And whatever we couldn't, we just needed more data sources. And then purple teaming was awesome because red team could start, and like we never really found red team until we did, even while we were just building it out. And when we were able to get them to like run an attack, see what we could detect, couldn't detect much, but then we built content on all the fingerprints they left. And in the data sources we didn't have, we now had justification like, hey, we need that data so we can find those fingerprints. And then we'd retest at the end of the week and catch them within like an hour or two of them starting their engagement. And then lastly, we got this really interesting log source that had all this valuable data, all this like interesting anomalous behavior, and as well as what is regular behavior, and a picture, like a big picture view into that was really helpful. So basically what I'm talking about, rather than that log source, right detection, out pops an alert, we're just putting an abstraction layer in the middle. And again, this is like Splunk's terminology, risk index, risk rule, but like you could use Kafka. I've seen it built with like a syslog forwarder. I know Sentinel can do like alerts and incidents. So there are other products and ways to do this, but this is the general premise, is that we are just taking our log sources, all of our different log sources, and writing observation rules. So they're just generating observations in a new log source where we're abstracting everything and using the same like shared field language so that they can all talk with each other. So when we throw an observation into the risk index, we can tag it with something like a risk score. I mean, I know we've all seen scores before, but it is still a useful way to aggregate. You can also throw in an attack tactic or CIS control or Lockheed Martin. I've seen insider risk people sort of just look for like reconnaissance, collection, exfiltration, and just sort of have 3 tactics because for their use case, that makes sense. I've also seen people take their previous incidents, like confirmed incidents, where because they were confirmed incidents, tons of forensics got done. So they were like, oh, all this stuff that we could have alerted on if we could build detections on it, now we can tag it with that metadata and then use that as an aggregate to alert on. And then lastly, just including the log source, because now you're making a new log source. So it's good to know, like, well, where did this log come from? So like tell it it's IDS or EDR or web or firewall or what have you. And then the thing I like about risk score, and you can deal with the other ones, and we'll talk about that as well, but is making it dynamic based on attributes about the risk object, like the thing we're tagging those events to. So for example, in Splunk, they call it risk factors. But whatever it is, it's really just lookups. Like look up this and then see and then tweak the score up and down. So we could have our asset priority in a lookup. Olaf Hartong, who's done incredible risk stuff, he talked yesterday, and he was doing a like bloodhound pathway mapping. So like I thought a really cool one, it was like, this is 2 steps from domain admin. Like that thing is an important thing. So when I see events on that object, just bump up the score automatically because it's probably more interesting and potentially malicious. Another great thing, you can just count the crit vulns on a machine, like run a vuln scan. If it's got 1 crit vuln on it, great. Now we know that when we see events on that, maybe it's more interesting to look at. Another fun one is business unit outlier. I love this idea of like, we have never seen this rule fire from this business unit, so automatically more interesting because now we're like making attributes out of our anomalies. And then, so this is like your index. This is your new log source that you're using. And now you're alerting on aggregates of those observations. So I like to think of this like every object in our environment is kind of like a bucket. And you just keep throwing observations in the bucket. But you only alert when the observations are like overflowing out of the bucket. There's so many interesting things there that maybe we should go look at it. So just a little terminology. Risk object is what we are latching events onto in that metadata. So example of system, a user. I've also seen people do cloud roles when like cloud roles are doing interesting things or first time seen things. That's really interesting to aggregate on. And then threat objects. This may not seem super cool initially, but I'll talk about how cool it is. And that's just the interactions or behavior of our risk object. So it's the thing that it did rather than the thing that's doing the thing. So this could be an IP address, file hash, registry key, command line, process, parent process. And you want to include as many as possible because you want to see when like a process, like let's say a lolbin with a new hash, that might be an interesting thing to alert on. So threat object, include as much of that information as possible when you're creating those events. So here's a sample of 10 things that I know personally I could never alert on. Really interesting things, new registry startup key, new scheduled task, low severity EDR, IDS alerts. But I could never alert on these personally, even though I really wanted to know when they happened. And when I was doing forensics and found them, I was like, oh, that's interesting. So with the risk index, now it's like every object in our environment, every bucket is looking for those 50, 100, 200, 500 interesting things so that we can alert in interesting ways. So an example of that would be just doing score. So if those 5 things fired, and we were, and because these are individual observations, this is like a period of time. It's not going to be a point in time alert because that's a one-to-one alert. So in this example, if our threshold was 100 over 24 hours, we would have caught them because our score popped over our threshold. If our threshold was multiple source types over 3 days, now we've got logs from 3 different source types, which like, you know, why is someone from HR firing IDS and EDR and the proxy and firewall? Or we could go even further with MITRE tactics over 7 days. Insider risk, I've often seen go 30, 60, 90, because you can just aggregate and look at things with just a more macroscopic view. And you don't necessarily have to alert on this. This could even just be like a threat hunting queue. Like I just want to look at what MITRE looks like over 30 days. I want to look at score over 30 days or source types over 30 days. So lots of interesting ways you can slice this up, and it doesn't necessarily have to be an alert. So this slide I made because of how common it was for me to like talk to a customer, and their perception of how things worked was that like, well, if we're not alerting right away, we're missing it. And what I think that sort of like misses is that if all you have is one-to-one alerts, that is all you're observing. Your observed events are exactly similar to your alerts. So that means ultimately you have blinders on what you're actually looking at. And so, and what often comes out of this is very low true positives because you're just looking at these certain things. And that's really all you're looking at. So there's a lot of security data that you're not really observing because it's only there for investigation purposes. So the idea with RBA is now you're looking at far more observed events. I mean, when this is mature, hundreds of thousands, millions of events per day, like, but it's still a vast reduction in total security data. So you may have like, you know, billions of security events or security relevant information, but ultimately your risk index is maybe 1% of that or less than 1% of that, but it's been brought down an order of magnitude in ways that you can do interesting alerts. And what this often ends up is a higher number of true positives and less alerts. So traditional detections are still great. We still need them. But I think there are attributes about them that we should keep in mind. And that is that they're high fidelity, low volume, and you can actually action when you see them. Like when this happens, the analyst does this. They reset the account. They nuke the machine. Those sorts of things. And they are point-in-time alerts. Like when I see this, I need this action to happen. With risk and observations, they can be any fidelity. I mean, it could even fire like PowerShell download string. Like let's say that happens in your environment from Chocolatey or a package manager. You could say, well, for Chocolatey download strings, like make that low risk or no risk. But any other time I see download string, keep it high. So the fidelity can be all over the place within the same alert, rather than just being like, this alert has this score. You can play with the score within the alert and sort of tune down things that maybe are not as interesting. And then it can be any volume. You can have an interesting event that you just kind of want to know about every time, like a new scheduled task or a new registry key in startup, because you're just making sure you know that it happened, not necessarily make an alert. So anything that is security relevant, great use case for an observational event. And again, these are period of time alerts. These are the unknown unknowns. Like until you build risk rules, you won't know what will bubble up, because it's this sort of like weird thing of like events coming from all these different places. And because it's over a period of time, there's definitely a learning curve, and that first month takes a lot of curation because you're finding a lot of weird things bubbling up. Often in development, people are like building RBA and they've curated it pretty well. And then there's like this monthly IT activity or like quarterly IT activity. And suddenly like, you know, all these like lull bin type rules are firing because that is normal IT administration activity. So I like seeing how things bubble up once you start building risk out. And then sort of along these lines to think about, with detections, ideally you can automate as much of that as possible. Like sometimes you're still going to need an analyst there, but those are the kinds of things you could automate end to end potentially, depending on like, you know, how that works and what tools you have. But period of time alerts, the automation makes more sense more for enrichment, so that when you're going to analyze, you have like more context to make that determination. And then response actions. So like when I see this, I want this to happen. So I mean, SOAR is great, but I think it has often been used to like, we're going to reduce alert volume with SOAR, but really you're only able to reduce volume of point-in-time high-fidelity alerts, because you don't want that other stuff that needs humans to look at it to be automated badly or incorrectly. So how do the talk thing? So I'm going to be talking Splunk SPL. I mean, it's basically SQL. I mean, I'm sure you could do this with SQL Magic and some scripts. But I'm just going to walk through piece by piece how that works and how you might do it. The requirements, as far as I know, this is just sort of, I'm so curious talking to people who have done things like this in different ways. I think the third one is not necessary, but I think it's cool. Regardless, you've got to have some way to tie up from all sources into a new layer with shared fields. So like a new log source that has shared field language that all your logs are now using because they're now in this abstraction layer. In Splunk, that's the collect command. Basically, it doesn't require any licensing because you pay for the indexing of the data. This is summarizing your data, so there's no additional licensing. You just collect to a new index, and now that's your index that you make aggregate alerts on. And in enterprise security, now that it's in product, it is called the risk analysis action for correlation searches. Next, you need to define risk scores and any other security metadata. I mentioned like MITRE ATT&CK, the log source it came from. You just want to throw those fields in there for like necessary information that would be really helpful when it comes up for analysis. In SPL, it's the incredible Swiss Army knife of eval. In enterprise security, you can also do that a little bit with risk factors. And then lastly, I think a really cool feature is being able to tweak scores up and down based on attributes about that object. So that's what I mentioned before with like the high priority assets or a business unit outlier or a crit vuln count. Regardless, in SPL, that would be the lookup command. And in enterprise security, you can use risk factors, or that's also part of the asset and identity lookup. Regardless, you can just anything you can do to look at another set of data and tweak the data you're ingesting right then. And then this is something that gets asked a lot of like, well, how do I score things? And it's an interesting question, and it's going to depend on your environment. We would just often take a detection, run it, see how many results there were, and based on the number of results, sort of guesstimate the risk score. But we use something like this, where impact was the effectiveness of the attack. Like, if I saw this and it was a true positive, how bad would that be? So in the original like pre-product RBA, impact was just a lookup of informational to critical of 0, 20, 40, 60, 80, 100. And then confidence was a multiplier of like informational at 0, 0.3 for low, 0.6 for medium, and 1 for high. So it just maintained that score with confidence, because then you could just play with confidence. Like in our environment, chocolatey with download string is informational. So I want to zero that out, but I still want PowerShell download string to be a high risk, potentially 80 or 100 for the risk score. So any result can be tuned down or out. I hesitate on outs only if there is huge swaths of regular business traffic that's not going to provide any analysis value. Go ahead and tune that out, because you don't need to know if it's like every object in your environment is connecting to that IP, or like that maybe is just creating noise that it makes it harder to find the other needles that would be actually valuable if you cleared out 90% of the noise. So just to give an example, the score is also only meaningful based on our threshold, especially because we're doing period of time alerting. So if I had scores like this for informational low, medium, and high, if we thought about the threshold of 100 over 24 hours, we see multiple ways that these could interact and bubble up together. So for example, you could have 2 lows, total 50, a medium, pop it over 100, 2 mediums be 100, 1 high, 1 low be 100, or 1 low, 3 informational, and 1 medium. All of these could bubble up to make something for you to look at. And that's really the power, is this like bubbling up in interesting ways. But we got to be smart about our scores and smart about our threshold. And don't move the threshold. Just set it and then start setting your scores around it. So to start talking about how you do it. So in this case, I'm just saying like, okay, here's our IDS Suricata data. And I'm just putting out the category by source IP, dest IP, signature. So there'll be a distinct event when there's a different source IP, dest IP, and signature. And then I brought out category because I'm going to use that to score. You may use priority inside Suricata, but we found it more useful because of the different noise levels of each category. For Trojan activity, I'll give it 25, for bad unknown 10, for web application attack 50. I don't know if y'all have played with Suricata data much, but they do have a priority system, and somehow policy violation is priority 1, which we didn't care about those alerts nearly that much. So something that might be smart to do is like, well, if I see in the signature ET info, let's just make info the category, and now let's make the category of info 0 risk, so that it is not, layering in on our scores, because we just saw so much noise from this stuff that we definitely wanted to know that it happened, but we didn't want it to contribute to an aggregated alert coming through the queue. So that's the skeleton. Then we're going to build the muscles. So I talked about risk object and threat object. It's also helpful to include the type as well to distinguish between different types of risk objects. In this case, our source IP is going to be our internal machine, and we're going to mark it as a system. And we're going to say our threat object, the thing that it did, the thing that it interacted with, is the dest IP, and we're going to say the threat object type is the IP. With another data source, you could have multiple threat objects. I think it's really useful to do that because you can slice it up in interesting ways on the back end. But just for example, just a one-to-one threat object. And then we'll include the source type it came from, Suricata, and include the event time, because we're making a new log source. So we want to make sure that the actual original event time is brought forward into our new log source, rather than when that log is being created. And then we, so Splunk ES in its implementation actually only has risk message, but I built it back in the day, and back in my day, we were doing risk message and risk info. And if you see the difference there, risk message is like a somewhat granular but still high overview of what happened, and risk info is where I included all other fields I might think are interesting. And the nice thing about that is like, if I had the risk message just more granular than the rule that it fired from, like it just tells me the signature and the source and the desk. That's helpful for throttling. So like if the same rule was firing over and over, if I included like bytes out and bytes in the risk message and then tried to throttle on it, every event would be unique and I could have the same rule fire a zillion times on the same crap. So I like risk info as just like a list of fields that would be useful for analysis later, depending on the source type. For IDS, we don't have that much, but for web and proxy, EDR, you can include all sorts of useful things there as well. And then we take all that. That's all the same stuff. Then we're going to throw on our MITRE tactic. So this Suricata, as far as I know, at least back in my day, it didn't have MITRE techniques and tactics tagged on that information. But we just like, well, we have a paintbrush we can use. Like if I see this category, I'll say it's Trojans, or if I see Trojans, I'll say it's this category. And what I thought was nice about this is it sort of like at least pins, according to the MITRE attack framework, like initial access execution, and then on the back end, sort of like C2 impacts, that sort of stuff. So at least we're like distinguishing events so that if we were aggregating on MITRE tactics, our IDS events still might be relevant and add interesting information to an alert. And then this is the skin. So in this example, I'm bringing in a lookup that looks at the source IP, outputs the host. If you have that, that's incredible. I know with DHCP and, or not DHCP, with VPNs and dynamic IPs, if you can get that, that's a gold mine to actually get the host name from IP. But in this case, we're adding the source priority and the source category. And then I'm just declaring a variable and adding at 0, and then adding to it when I see certain things. The reason that's like another eval command over and over is because with the if or case statement, the first match does the thing and then doesn't care about the rest. So I want to look for each one of those categories and the priority. And if I see it, just add 1 to my 0 so that by the end, I can tweak the score based on the count that I received at the end. So I could also do what I said of the crit vulns. And if I just had a lookup of like this host has this many crit vulns, output the number of crit vulns, add that to my modification count that I was looking for like production or database or critical or high. And then the math I'm doing here, I'm doing the risk score times this count that I just built up times 0.25 and then adding 1 because doubling risk score is a lot. Like that things will quickly like spiral out of control if you double it. So I decided to quarter it. But if something hit with a production database, critical asset, and had a crit vuln, that's risk mod count of 4 times 0.25. So 1 plus 1, the risk score gets doubled, but that's 4 things that it hit on. So generally, I'm wary of multiplicative stuff, and you might need to mess with this math so that it doesn't like bubble up too many interesting things because it can get a little muddled. But that's one way of doing it. And then the final piece is collecting it, like bringing it into a new log source. So in Splunk, you can use the collect command, tell it what index to go to. And then we're just making sure we have all of those fields. So it's the risk object type, the threat object type, it's the source type and the event time, and the MITRE attack risk message and risk information, and the MITRE attack information or whatever framework you want to use. Make up your own. Regardless, you can do whatever you want here, but I think mainly those top 4 are kind of essential, or just there's a lot you can do there when you have an abstraction layer that is all speaking on that same language so that you can look at it in interesting ways and parse it out in interesting ways. So how do we alert on it? Well, now that we have a new index, let's just break out the number of distinct tactics, techniques, sources, and sum the score by our objects. And now we could alert by the score going over 100, or we could alert on more than 2 sources from a single risk object, or we could say when we see tactics, more than 2 tactics or techniques, and from more than 1 source type, then go ahead and give us an alert. And again, we can do this with different time frames. I like the idea of having one time frame that you use it for, like that you actually alert on and analysts respond to, and then other time frames that are just kind of cues to look at, like interesting ways to look at your data and how things are bubbling up. which is where I say that. So another cool thing, I hope this comes across well, because I think this is a really powerful way of using this data. Someone within Splunk came up with this handy way of like, because a risk rule can just fire over and over, like let's say it's a proxy rule, and that domain, individual URLs are firing over and over and over and over, and you're like, okay, but really it's just one domain. A smart way of doing that is like, well, if a single risk score times 2 is lower than the sum from that source that's generating those events, just max it out at the top risk score times 2, because I don't want to know that a 10 score event fired 300 times. I just want like, okay, let's add 20 to that, so it doesn't like pop up in our alerting queues, and we can still make meaningful analysis out of it. So that's one piece we could do. The next thing I like adding on top of that, because score is a little easier to play with, but that other metadata, the difficult part would be if you're just counting like number of MITRE tactics or number of sources. It's like, well, is a score 0 event or score 1, should it count as a full tactic when you're counting by distinct tactics? And I don't think so. So I would do something like this, where if the score is above 70, I'm subtracting from 1, that's why the numbers are reversed. But if the score is above 70, make it count as a full tactic. If it's between 40 and 70, let's count it as half a rule, as a treat. And if it's between 5 and 40, let's count it as quarter of a rule. And then if it's between 0 and 5, let's just not count it as a MITRE tactic occurring, because it's such a low risk score that is probably less relevant in the context of MITRE as well. And there's a lot of ways you can play with this. This is the math. My slides will be up later. Basically, I'm just subtracting from 1 to make that score count as that many things in a context of counting MITRE rules or counting source types. But that's SPL. You probably won't need that, but that's the idea. I just like tweaking my counts based on my scores, because I think that provides a lot more value. Another cool thing you can do to get more value, depending on the types of things that are bubbling up, is, again, using that thing where you declare a variable, and then when you see this, like pop up the score. So in this case, I'm like, well, if sorts types was a multi-value field, if I see endpoint in there, well, let's just pop up this randomly declared value. Let's pop it up 20. And I could do a few more. So with malware, I'll add 20. But web and DLP, we haven't been finding as much high fidelity alerting, so maybe we'll just bump it up 10. And then we could do things like from IDS, well, highs and criticals, I'll bump it up 20, like endpoint and malware do. But if it's not high or critical, maybe we'll just bump it up 10. And then if I made a threshold of 39, you'll see that, I purposely chose 39. And I'll talk about why in a second, because you can see 2 20s or 4 10s or 2 10s and 1 20. All of those will go over that threshold. And that's what I mean about our threshold being really important to define what alerts. Because I chose 39, because in this case, the logic I'm basically recreating is that I want 2 of endpoint malware IDS high critical, or 1 of those, and 2 of web DLP IDS low mediums, or 4 of our lows. So you could get a lot more complex with this logic. The more data sources you have, the more like distinctions you want to make. But metascoring is really powerful for metadata aggregation alerting. Another way we could do that to include the other cool stuff we added to risk score that is not now relevant in our metadata is now we could include, let's say we have a user list and we have the user category, and we have our vulnerability list that we used previously. So now if we import that data, we could include that in the count as well, where if I see any of those user categories bump up that modification to that declared value by 10, or if I see that the crit vuln count is above 0, then pop it up 20. So now this is adding all sorts of additional interesting ways that this will bubble up based on attributes about the objects we're looking at, which so you can do so much cool stuff with this. So what do now? What can you do with all this cool stuff? And I hope you've already gotten some ideas, and I am more than happy to talk about ideas and what you've already got going. Because so many people are doing cool stuff with something like this, and they may not even be calling it RBA. They're like, well, I figured this out on my own, and I'm doing it in this cool way. So what I think is really cool is like this then that alerts, like something that if I just want to know that it happens, but I could never alert on it ever, make the risk score 0. But then think about interesting ways that two things that by themselves, interesting observations together are fascinating. So an analyst of ours came up with a really great example of Adobe Acrobat spawning a web browser. So much of our phishing is like a PDF with one URL, you click into it, happens thousands, if not tens of thousands of times in a huge enterprise. So you can like tune out some like normal business traffic because that web browser spawn also includes in the command line the URLs, so you can throw out some URLs. But the other one, proxy connection to uncategorized sites. So that is often new attacker infrastructure or like little tiny small business websites that attackers compromise and host their infrastructure on. So by themselves, like that happens all the time. 0 risk. I don't ever want to alert on that. But those things within 5 minutes of each other was a very reliable phishing catcher. Like we threw those rules in for that analyst, and then we're like, okay, next week we'll see how it does when they start playing together. And then when we ran the alert for like those two things within 5 minutes, every single event, and both of those were like thousands of events per day, that was a confirmed phish every single time. And I just thought that was so cool because it was a brilliant, like an analyst taking things that he knows happens, but when they happen together, it was so much more reliable than by themselves. Another one I came up with that Red Team hated was I had detections for all of those common reconnaissance rules, system info, netstat, who am I, query, ping. I even had dir, which like I had to do a decent amount of tuning because there was a lot of scripts running that used dir, but it's such a it's like a command to navigate through a machine. So I could score that as 0. Like I don't want to alert on that ever. A lot of these were, you know, varying risk of like 0 to 25 because I never really wanted them to contribute too much. But then I made a rule on top of that for when you see 3 of those, maybe that's like 50 risk. When you see 5 of those, that's like 80, 90. You see 7 of those, that's a direct alert. Like just go look at it. The only person doing that is a red teamer or an actual compromise. And that was a very reliable C2 catcher. And what I loved about that was that like once we kept catching red teams, then they had to make new techniques. They had to change up their TTPs. And that's where they shifted to like DLLs that were hiding commands so that our EDR wasn't picking up the commands. And now we had to get better by finding network anomalies, but making network anomaly risk rules that like stuff that by themselves weren't interesting. But when we saw 3 weird network anomalies, then it became an alert. And that's how we pivoted to finding their infrastructure. So very cool stuff. And now I get to talk about my favorite part. I feel like I've already been like this the entire presentation. But this is the thing I'm really passionate about, which is threat objects, because it does something so cool. And it might not seem cool. It's like, oh, yeah, it's the thing that it did. Yeah, OK. But it is awesome. It is amazing. And the cool thing about it is that, well, for one, you can find noise. Because threat object, you're tracking behavior. So like you're seeing the stuff that happens all the damn time. And if it's on the same rule, like that one rule is creating tens of thousands of risks versus your other rules that look at one thing are generating a few hundred or a few thousand. Like 10,000, 100,000 for a rule that's like ingesting all your IDS SIGs or EDR SIGs, that makes sense. But a rule that's doing one thing should not be making that much risk. So if you see like something like this, you'll see frequent sysadmin stuff, IT scripts, and vuln crawling type stuff. We'll be doing this pretty commonly, so at least you may not need to tune it out, but at least you could tune it down because this is now making noise. Like what often happens is like every alert that fires has that rule in it. Like every time that rule is there, and it's over contributing. So that is an easy way to find it when you're looking at threat object because you're now seeing the things that happen all the time. A really nice way I like of breaking that out is looking at a threat object by distinct other objects. So how many distinct, and this is very small sample data. In an enterprise, it's a lot more interesting, but distinct risk objects, distinct threat objects, distinct sources, distinct desks, distinct users, and distinct business units. This is often an interesting way to frame, like, well, field services, like the DC business unit 1, field services or service desk, they're often doing that lolbin stuff. You'll see them there all the time, and it'll be like firing on 20 objects, which is the 20 employees from the one business unit. And you're like, oh, okay. For field services, like when I see those from that business unit, I'll tune that down. Anyone else, it stays very high risk. So it's still really valuable when it happens in other contexts. So I think there's a really great way of breaking this down. If you do use Splunk and you have RBA, we have an app on the Splunk base called Threat Object Fun, which has all these dashboards built in. But you can also just pull that XML and look at it and get ideas for dashboards and other tools. The other thing is that often when you're tuning, it becomes hunting, because you will find interesting things when you start looking at like, well, what risk objects is this rule firing on? And we were just, play data. We weren't searching for anything in particular. But this is where we found this PowerShell thing where 7-zip was running all the time and making noise. But we're like, oh, but then it's firing with how to restore my files, which is an interesting combination of like, well, we were tracking the process of PowerShell, but then we also had the threat object of file name. And now PowerShell is making a file name. And it's the first time seen. It's only on that one machine. And I mean, it generated a bunch of risk as well. So we would have found it that way. But it was interesting that while we were pivoting, looking through our data set, we found stuff like this. And that's the really cool part about threat object. Like I just did a training, a Velociraptor training with the awesome Eric Capuano and Whitney Champion this week. And so much of what we were doing with Velociraptor was like breaking out the interesting fields, which is what we would use for our abstracted shared language of what we're looking at, but then also sorting by count. Like I only want to see the thing that happened on one machine in our whole environment. So that's where threat object shines. And I don't know if any of y'all have played with Chronicle, and I'm not going to say anything bad. Only the good thing is that it has prevalence, is the coolest feature. You get a timeline, and you get this thing of like, this only happened once, and it sticks out like a sore thumb, and it's great for analysis, that investigation timeline. So threat object is a way that you can sort of recreate this feature and like look at things that are anomalous in your environment, especially when you're like, well, you're tracking process name of PowerShell and or let's say a lolbin instead. But then it's firing with a new hash. Or we're seeing this parent process that we see all the time, but it's firing with a new sub-process or connecting to a new IP. There's just, when you think about like threat objects together, like finding the anomalous things they do together is really, really interesting, and you can find all sorts of cool stuff. So yeah, looking for rare objects, head scratchers, or things that pop out and are a little bit weird. Just looking at threat objects just by like, I only want to see the things that happen once. You can often just sort of scroll through and be like, what the hell is that? Is just another example of the file name being observed with the process. So what else can you do? Beyond threat object, I think I mentioned this earlier, purple teams become so much more valuable when you can create rules that are on fingerprints, like not one-to-one detections, but one-to-one observations, because like, that's where they did that. That's where they touched that. That's the really cool stuff you can do when red and blue team are working together. So you can see what content you can make based on the data sources you have, and make finger detections on or observations of any of those fingerprints. Or if you don't have that data, you know that they left a mark somewhere, but you don't have that data in whatever tool you're using to look at logs, it makes a great business case. Like, oh, we could find red team better if we had this data source. Find every fingerprint, make new content, and now retest at the end of the week, and you'll probably catch them a lot earlier in the attack cycle. I mentioned this briefly before. Those teams have great data, but it is very rare for it to be high fidelity. I've seen incredible teams do wild Excel magic to like export their stuff and then like cross-correlate alerts, and they're basically doing RBA. But insider great risk, the nice thing about it is it's a scoped use case. Like malicious compromise is all your data is valuable for security. And insider risk is like, well, I want to know network traffic. I want to know like weird file stuff and maybe a few other things. So it's scoped so much tighter. So it's way easier to build something that's high value. A friend of mine, Matt Snyder from VMware, he has a talk at Splunks.conf 20 talking about his insider risk program and what they were able to do. Fascinating. And then at MITRE ATT&CK conference last year, it's a shorter talk, but it's more about the nitty gritty, like what detections did he have and how did you distinguish between malicious insider and unintentional insider, because you could group it in different ways based off the types of rules that they fired on. And then another really cool one, oh my gosh, the customers doing this stuff is so cool, is so like fraud or account takeover or DDoS or bot detection. When you shift to like, so I don't generally recommend making risk objects out of external IPs, but if you're doing this type of work, the cool thing you can do is like make your threat objects like signatures of their behavior. So like if you have Akamai data or something that shows they're like, I went to this page, then this page, then this page, but I did it in like 30 milliseconds each time, that's probably an automated tool. Or like when you see IPs submitting stuff to credential pages, like you can make a lot of interesting behavioral, like this is a thing that does this. And now you've got like a punch card of like this IP did these 4 weird things. Now search backwards on that and show me every IP that has that exact same punch card. Oh, 5,000 IPs, block them all at once. And it's so cool what the customers are doing with this stuff because you're able to deal with that like huge traffic influx and then map that behavior to attackers and their infrastructure and ban them all at once. Super cool. And then all my friends that are doing ML, basically they're justifying to leadership, like, please give us time to build a clean data set. Please just don't make us do ML just out of the gate. And so what's nice about RBA is it plays really well as an ML data source, especially once you start making a lot of events. Because aggregated alerting, you'll find interesting ways of like manually bringing that up, but ML is going to find those weird nooks and crannies of things you could have never imagined. And then if you're adding in the metadata of your disposition, like when an analyst is like, this was bad, now you've got additional metadata for ML to use. It's like, oh, these are the kinds of things that show up in things that are actually bad. So the stuff you can do with ML, great data set. So to review before my battery runs out, we were talking about risk-based alerting or aggregated abstraction alerting or whatever the hell you want to call it, just as long as you do it and tell people how to do it. Because whenever I do this talk, it's like 10% of people are like, oh yeah, I do that. And then 90% of people are like, why didn't nobody tell me to do it this way? Because it's just something that hasn't reached, like, we don't have shared language about it. We've said like correlation for a long time, and some people have taken that and run with it and done this exact thing. But other people are working with security tools and they keep getting more use cases they have to make, and they just make more and more alerts. And then all their analysts are sad, and then we're all sad. So we talked about how we do that, of like making a new data source and the fields we use to do that. So risk object type, threat object type, the source that it came from, the event time that it actually happened in the original log, the risk message as a abstraction of what happened, and then the risk info for all the detail of what happened. And then lastly, any framework that we want to include. I mean, obviously, you can include any security metadata you want. It's just I think those shared ones are really important because there's lots of cool stuff you can do when aggregating like that. And what you can do now, I hesitate to say everything, but like every time I talk to someone doing it, they're doing something cool I hadn't thought of. And once you build out that base, you can kind of just keep bolting in features. Like you may not have crit vulns when you start, but like someone's like, oh, we threw Qualys data in there. Or like, oh, great, we have Qualys data. So you can like instantly make that lookup, instantly start providing value to the framework you already built out. So there's lots of cool stuff you can just keep bolting on. You can keep making detections, and you can keep tweaking how it aggregates or how you hunt it, or the dashboards that you build for analysts. Like, well, when this risk event fires, if I want to investigate that, I want a dashboard that does this. And so you can smooth out process, smooth out workflow. So much cool stuff you can do. I think that is everything. And yeah, so that's my website. I'll put my slides up there. And yeah, thank you so much for coming. All right, any cues? This question was like, what is the like correct order of operations for the shifts to this alerting methodology? So I did build a 60-page PDF for like building like front to back, like how and why, not just documentation, like here's how to do it, like turn it on and now it works. No, I was like trying to explain every step of the way. It's called the Essential Guide to Risk-Based Alerting. I mean, basically it's like you're starting with just making rules, just making noise, just so you could see what happens. And then you're in the curation stage where you're building more content, but curating at the same time. So your risk doesn't like blow out of control and you're still getting value. Then you got to get ready to operationalize, get it ready for the SOC where they have process and response templates so that they can actually investigate risk in a logical way. And then you're putting it in production. That's the gist of it. But ultimately, it's a journey. Like I would say most places take 3 to 6 months to fully put this in production. I think better safe than sorry and slow and steady.
Seems to me that risk-based alerting has good candidates for quantum computing primitive algorithms. Is there a potential in this field for advancement?
Oh my gosh.
And there's a little more. Essentially, quantum computing algorithms typically play well with small input and small output. And because RBA tags objects with weights, it seems like there is good potential for applying these rules on quantum computing
oh my God.
systems.
I can imagine. I am not smart enough to know, but that sounds super cool. My original coworkers, we often talked about like using RBA for like literally anything that's like hard to alert on, but would be interesting to surface alerts from. So we were thinking like, well, if I had my health data and I had like like vitamin checks and like all sorts of blood levels and stuff, and then I had like risk factors that tweak those scores up and down based off my family and genetic history. Like it is a smart way of aggregating data. There's lots of different like applications to this that isn't just security tooling. So quantum computing will, I'm sure, will be another one. And after it cracks all encryption, we'll all be screwed anyway. So.